All right, so let's go ahead and review the concept of graphing quadratics in standard form, which is the form y equals ax squared plus bx plus c. Remember that a is the coefficient of x squared, b is the coefficient of x, and c is the constant at the end. So I want to go ahead and use the function here, y equals negative x squared plus 6x minus 2. And the first thing we're going to do is we're going to make our list of items that we are going to identify and find. So A, B, C. We need to find X, which is the axis of symmetry. We need to find the vertex. We need to find or identify the y-intercept. And we need at least 2 more points that we can use to graph our parabola. Okay, the easy part of this is to identify A, B, C, because again, A is the coefficient of x squared, so here's is negative 1. B is the coefficient of x, which is 6, and C is the constant, which is negative 2. And we can also see that C is the y-intercept, because in order to find the y-intercept, I would turn x into 0. I would use the value of 0 for x, which basically end up with 0 plus 0 minus 2. So you can see here that the C value of negative 2 is always going to be left there as the y-intercept. So the y-intercept is 0, C, which in this case is negative 2. So we have already found half of the pieces of information that we need to find in order to graph this quadratic, in order to graph this parabola. So next we're going to find the x value, the axis of symmetry. Remember, we use the formula x equals negative b over 2a. And as I always tell you, you want to use parentheses. Parentheses are your friends. So negative parentheses over 2 parentheses. We're going to plug in our b value up here. B is 6. And our a value down here, which is negative 1. And then work this out. So here we have negative 6 over 2 times negative 1 is negative 2. And 6 divided by negative 6 divided by negative 2 is positive 3. So now we know where our axis of symmetry is. It's the line at x equals 3. And so we can go to our graph and graph a dotted line for x equals 3. We want it to be a dotted line because it's not actually part of the parabola. It's just the middle, the center of the parabola. Next, since we found the x value, the axis of symmetry, that x value is also the x coordinate of the vertex. So all we need is the y coordinate. The way we find that is we're going to plug in the x value of 3 into this function y equals negative x squared plus 6x minus 2. You always want to use parentheses to make sure you don't make any mistakes. So I'm going to say y equals negative parentheses for the first x squared plus 6 and a parentheses for this next x and then minus 2. Because the parentheses keep you from making silly mistakes. We're going to plug in a 3 here because we found that x equals 3, and we're going to work this out. So 3 squared is 9. If you see this negative here, this negative was not inside the parentheses, so it did not go away when we squared. It's still here. So we bring it down. And then 6 times 3 is 18 minus 2. So we have here negative 9 plus 18 is positive 9. And 9 minus 2 is 7. So now we know what the y-coordinate of the vertex is. It is 7. So the vertex is at 3, 7. And the y-intercept is at 0, negative 2. Let's go ahead and plot those points. So we go 3, 7. And the y-intercept is at 0, negative 2 right here. Okay, so now for the final part, or the second to last part, is we need to find at least 2 more points. And the important thing is that these 2 more points we're going to find need to be on the same side of the axis of symmetry as the y-intercept. Because we're going to use the concept of symmetry and do that, the reflection for the mirror image to get the other side. So if you see here, the y-intercept is on the left of the axis of symmetry. So we want to pick at least 2 points on that are also on the left side of the axis of symmetry. I'm actually going to go ahead and do 3 because there are 3 that fit here. So I'm going to pick here 2, 1, and -1. So I'm just going to put a third point here. And we're going to go ahead and do this. So first, if x is 2, what's y going to be? So we're going to plug our 2 in here and work this out. 2 squared is 4. We bring down this negative. 6 times 2 is 12 minus 2. So we have -4 plus 12 is 8. And 8 minus 2 is 6. So we have the point 2, 6. So I'll go here and I plot that point. Let me make sure I put in blue. 2, 6. Okay, my next point I'm going to choose is what if x is 1? What will my y value be? So I'm going to come back in here and I'm going to plug in a 1 for my x value. So here 1 squared is 1. Bring down this negative. 6 times 1 is 6 minus 2. So -1 plus 6 minus 2. -1 plus 6 is 5. And 5 minus 2 is 3. So I have the point 1, 3. We'll plot that. And let's go ahead and do one more point here. What if x is, we already have 0, so let's do -1. Now some of you might think, well, -1 and 1, same thing. Nope, it's not the same thing. When they're squared, they're the same, but the rest is not the same. So if I put a -1 in here, -1 squared is still +1, and I still have to bring down this negative sign here. But now here, 6 times -1 is now -6, not +6, minus 2. So -1 minus 6 minus 2, -1 minus 6 is -7, and -7 minus 2 is -9. So when x is -1, y is -9. And we go down here, we plot this point, -1, -9. You can see here that we have one complete side of the parabola. And all we have to do in order to complete the parabola is take each of these 4 points here that I have and reflect them across the axis of symmetry to get the other side. So this point here is 1 unit to the left, so its partner will be 1 unit to the right. This point is 2 units to the left, so its partner will be 2 units to the right. This point here is 3 units to the left, so its partner will be 3 units to the right. And this point here is 4 units to the left, and its partner will be 4 units to the right. And so here is our parabola. I don't have the steadiest hand, so it doesn't come out perfect, but you get the idea. Okay, I hope that this helps you understand how to graph quadratics in standard form, y equals ax squared plus bx plus c.